Good afternoon. Today is Wednesday, October the 7th. In pre-calculus today, we got into section 3.3 and started talking about some of the properties of logarithms. So I will share my screen and show you some of the key concepts that you need to look at here. So we have three basic rules when we're dealing with logarithms. I'll go ahead and type them out here. The first one says if you have the log, I'll put the base here in a second, of a product, the formula says you have the sum of the logs, so you'd have log of x plus log of y. Now your base here can be anything, so we'll just go ahead and leave it like this. Remember, if I have nothing there, that means my base is 10. Okay, the second rule says the log of a quotient, so log of x divided by y is equal to the difference, so that would be log x minus log y. And then the third rule says if I have a log x to a power, and I'll put the power in with a pen here, it is equal to the power, which we call p, times the log of x. So in this case, there would be the p would be a power here on the x. So log base x to a power, you can basically, all it's saying is you can take the power and bring it out front. So if you look at a couple of problems, like if I have, for instance, I come over here and I have log base log base 4 of the fifth root. So this is the fifth root of 64. Then I can rewrite this and take my log base 4 of the fifth root and change the fifth root to an exponential or a rational exponent. So I got the log base 4 of 64 to the 1/5 power. Now, remember, if I have 64 here is 4 cubed. So if I go ahead and change 64 into, so I've got log base 4 of 4 cubed. And I'm raising that to the 1/5 power. Remember, if I'm raising a power to a power, I multiply. So I get log base 4 of 4 to the 3/5 power. And I can take, if I use my third rule here, I can take the 3/5 out front, which is what the third rule says I can do. So I have 3/5, and I'm multiplying that by log base 4 of 4. And remember, log base 4 of 4, anytime the base and the argument are the same. I'm basically saying what power do I raise 4 to get 4? And the answer is 1. So my problem here is the answer is just the 3/5. Okay, so now that's one type of problem. Now the other thing, if you look, I'll come down here across the bottom, you can use these to expand an expression. Like if I give you something like the log of, well, I'll put this in text. If I give you something like the log of 12x to the 5th times y to the -2 power. Now, so up here, my rule says if I'm multiplying, I add, and in all the cases here, I'm multiplying, so I can say this is equal to the log of 12 plus log of x to the 5th power plus the log of y to the -2 power. So I've used the first rule, which says if I'm multiplying, I add, and then I can come down here and use the last rule, which says if I have the log of a expression to a power, I can bring the power out front. So the final expression here is the log of 12 plus 5 times the log of x minus 2 times the log of y. So that's a second type of problem, and the problem generally will state that you want to write the expression with no powers greater than 1. So you've got no powers greater than 1. Now, the other type of problem is something basically where you just take the same type of thing. So like, let's say I come over here to over here. So now I'm going to have something like I've got 4 log x minus 1/3 times the log of x plus 6. And I want to condense this. So I want to go backwards. In other words, I started from a condensed version here and I went to an expanded version. So now I want to go backwards. So the first thing I will always do is I will take these coefficients here and I will use this third rule to change them into exponents. So I come down here, now I have log x to the 4th power minus log x plus 6 to the 1/3 power. And then, since if it says up here, since I'm multiplying, I add. If I'm dividing, I subtract. So I'm going backwards. So if I'm subtracting, then I'm going to divide. So my final answer here is the log of parentheses x at 4 on the top divided by x plus 6 to the 1/3 power on the bottom. Because if I'm adding, I multiply. If I'm subtracting, I divide. So those are the types of problems that we did today in class. If you look through your homework assignment, you've got basically one of each. There's one other type of problem I can show you here. If you look, for instance, if I want to take, and I'll get rid of this here, so I'm going to erase this upper corner here. so I can work in here. All right, now, so I will come back up to here and I will put in what you want to do. You want to take something like the natural log of, say, the natural log of 75. Okay, we'll do 75 and write this in terms of the natural log of 3 and the natural log of 5. So now if you go back to the, and I just erased the rules over here, but if you remember, if you look, the natural log of 3 and the natural log of 5, I can take 75 and I can break it apart into the natural log of 3 times, so I got the natural log here, I'm going to put this in. So natural log of 3 times 25. And then if I break this down, so remember if I'm multiplying, I add. So I have the natural log of 3 plus the natural log of 25. And then the natural log of 25 is the natural log of 5 squared. So the natural log of 3 plus the natural log of 5 squared. And I can take the 2 since it's an exponent. So now I have the natural log of 3 plus 2 times the natural log of 5. So I have written the natural log of 75 in terms of the natural log of 3 and the natural log of 5. Now, the purpose of this type of problem is just to get you familiar with the manipulation of these 3 formulas that are the basic formulas that you use with logarithms. So once again, look at your homework. If you have questions, send me an email and I will get back to you. So I will stop sharing now and pause the recording. I'll see you again tomorrow afternoon.